Good morning, everybody. Last time we have to explain gases law. In gases law, we have to introduce Boyle's law, Gay-Lussac law, Charles law, and so on. So I repeat this gases law again and again. So first I repeat Boyle's law. At constant absolute temperature or at constant temperature, pressure is inversely proportional to the volume. In this case, pressure is inversely proportional to the volume. So proportionality equation of this Boyle's law, P proportional to 1 upon V at constant T. Second, Charles law. Charles law states that fixed mass of a gas or volume is directly proportional to the absolute temperature at constant pressure. This is Charles law. Then Gay-Lussac law. At constant volume, pressure is directly proportional to the absolute temperature when fixed mass of a gas in the container. So this is our Boyle's law. Then ideal gas equation, or in gases law, in all these laws, Boyle's law, Charles law and Gay-Lussac law, we have to consider old pressure and old volume, new pressure and new volume. P1 V1 equal to P2 V2 in case of Boyle's law, V1 upon T1 equal to V2 upon T2 in case of Charles law, P1 upon T1 equal to P2 upon T2 in case of Gay-Lussac law. So here is all these parameter is very important for your review of examination. Here P is the pressure of the gas, V is the volume of the gas, T is the absolute temperature of the gas or temperature of the gas, K constant, P1 old pressure or initial pressure, T1 old temperature or initial temperature, V1 old volume or initial volume, P2 new pressure or final pressure, T2 new pressure and new temperature or final temperature, and V2 new volume or final volume. Then perfect gas equation. We know that two equation, Charles law. Charles law, V proportional to T at constant P, and Gay-Lussac law, P proportional to T at constant P. So from these two proportionality constant, we can write P V equal to KT. This is the Charles law, and P equal to KV. So from these two equations we can write PV equal to KT. From Boyle's law and from Gay-Lussac law, both equations we have to consider, and next equation, that is perfect gas equation, PV equal to KT. Here P is the pressure of the gas, V is the volume of the gas, K is the constant, and T be the absolute temperature. Here K is gas constant or simply constant. So K is called gas constant, and which depends on the mass of the gas, keep in your mind. K is the gas constant, and this K depends on the mass of the gas. So equation shows ideal gas equation. This PV equal to KT is called ideal gas equation. Value of K is same of all gases. Value of K is same for of all gases, and therefore we have to remove K, or instead of K by R. So our equation PV equal to RT. And R is general gas equation. Keep in your mind. Here is R is general gas equation, and here is P equal to KT, KV the gas constant. So equation shows general gas equation. This is PV equal to RT, and ideal gas equation PV equal to KT. This PV equal to KT when we have to remove K. Why? Value of K is same for all gases, and therefore instead of K we can write R. So this is PV equal to RT is the general gas equation. Here is R is universal gas constant. R is universal gas constant, and here K is a gas constant. Keep in your mind. So this is the perfect gas equation. Then specific heat of gas. Specific heat of gas. It is defined as the amount of heat is required in joule. The amount of heat is required in joule to increase the temperature of 1 kg of a substance by 1 degree Celsius. Specific heat of gas. So the specific heat of gas constant or substance is defined as the amount of heat is required in joule to increase the temperature. To increase, not decrease. Keep in your mind, increase. To increase the temperature of 1 kg of substance by 1 degree Celsius. And unit of specific heat of gas is CGS unit, calorie per gram degree Kelvin. MKS unit, kilocalorie per gram degree Kelvin. And SI unit of specific heat is joule per kg degree Kelvin. So, in case of specific heat of gas, solid and liquid have only one specific heat. Solid and liquid have only one specific heat because small change in temperature causes negligible change. Small change in temperature, small change, it means like negligible temperature change in volume or pressure. So, external work done is negligible and heat supplied is used only to rise the temperature. Keep in your mind. Solid and liquid have only one specific heat because small change in temperature that causes negligible change in volume or pressure. So external work done negligible and heat supplied is used only to rise the temperature. So here, this specific heat, again I repeat the definition of specific heat, the amount of heat is required in joule to increase the temperature of 1 kg of substance by 1 degree Celsius. And unit of specific heat of gas is CGS unit, calorie per gram degree Kelvin, MKS unit, kilocalorie per gram degree Kelvin, and SI unit, joule kg degree Kelvin. And the specific heat of gas are two types. Specific heat of gas are two types. Number one, specific heat of gas at constant volume is denoted by Cv. Specific heat of gas at constant volume is denoted by Cv, and specific heat of gas at constant pressure denoted by Cp. Specific heat of gas at constant pressure denoted by Cp. This is two type of specific heat of gas. The specific heat of gas denoted by specific heat of gas are two types. Number one, specific heat of gas at constant volume. At constant volume, that denoted by Cp. And specific heat of gas at constant pressure, that denoted by Cp. So specific heat of gas at constant volume, it is defined as the amount of heat is required in joule to increase the temperature of 1 kg gas by 1 degree Kelvin at constant volume. At constant volume. Only in the definition you have to write last at constant volume. Same definition of specific heat of gas. What I am saying, the specific heat of gas is defined as the amount of heat is required in joule to increase the temperature of 1 kg gas by 1 degree Kelvin. This is the definition of specific heat of gas. Now, I explain the definition of specific heat of gas at constant volume. The amount of heat is required in joule to increase the temperature of 1 kg gas by 1 degree Kelvin at constant volume. And in this case, at constant volume to increase the temperature of the gas. In this case, at constant volume to increase the temperature of the gas. In this specific heat of gas at constant volume, volume constant and to increase the temperature. Then second point, specific heat of gas at constant pressure. So it is defined as the amount of heat is required in joule to increase the temperature of 1 kg gas by 1 degree Kelvin at constant pressure. So in this case, pressure remain constant, pressure remains same, volume of the gas increases. Volume of the gas increases in case of specific heat of gas at constant pressure. Again, I repeat this definition, specific heat of gas at constant volume. The amount of heat is required in joules to increase the temperature of 1 kg gas by 1 degree Kelvin at constant volume. In specific heat of gas at constant volume, volume remains same or volume remains constant to increase the temperature of the gas. In case of specific heat of gas at constant pressure, the amount of heat is required in joule to increase the temperature of 1 kg gas by 1 degree Kelvin at constant pressure. In this case, pressure remains constant, volume of the gas increases. So, student, today I stop here. Thank you very much.